Hello folks, we come to the miscellaneous exercise chapter 7 and this is a part 5 video where we are doing the last two problems in the exercise. In the previous part we had seen the last question, which was our question number 9, where we had done those seating arrangement of men and women, where the women would occupy even places and the men would come and sit in between so that the women don't sit and gossip. Probably that would be the idea of that person, the person who's arranging, the event manager behind having that kind of sitting done. Yeah, we had seen that interesting problem, and now we are coming up to our routine kind of problems. This is our 10th question. Let's see what it says. It says that from a class of 25 students, 10 have to be chosen for an excursion party. Out of 25, you are choosing only 10. I don't know what happens to the remaining. There are 3 students who decide either all of them will join or none of them will join. In how many ways can this excursion party be chosen? So, first of all, out of the 25, only 10 are chosen for the excursion party. And in that excursion party also, in amongst that 10, there are some 3 elite members. I don't know what is so special about them. It is such that if one person joins, all the 3 will join. But suppose if that one person decides not to join, then all the 3 will not join. I don't know what could be the reason. Maybe they are like, triplets, like how we have twins, like the triplets. So maybe there is one bossy character. He doesn't come means all the 3 won't come, or he comes means all the 3 will come. Maybe something like that. Could be. That could be one case. Okay. Having had that case, how do we go about solving this problem is, if out of 25 you are choosing 10 people, as I said, if there is no condition in how many ways you can do it, 25 see 10, but there are conditions. So we will adhere to the conditions. 2 cases. First case is where all 3 will join. Second case, when all the 3 won't join. So case where all the 3 are joining. See, this is like our courses problem in that combination exercise, that there is a program where so many courses are there, and if that is compulsory, then that compulsory thing goes away from the choice, and from everywhere it gets chopped off, and you do only for the remaining. It's something like that, right? 3 of them are joining, so you know they are joining, right? Because you know they are joining, they are not there in the we are not choosing them at all. They have joined, we have to have 10 people, 3 already joined, now only the remaining 7 have to come, right? So they are joining, only 7 have to come. So you have to choose how many? You have to choose only 7 people. Now these 7 people, from where you have to choose? 3 have already gone from the total, right? They have already kept aside. So you have only 22 people from where these 7 have to join. So it's basically 22C7 that you have to do for making the choice. That was a case when they join. Now there is a case where they don't join. They will not join. So if they are not joining, from my class of 25, I have removed A, B, C. Go away, come on, go to the next class and sit, because you are not joining. Go and sit in the next class. So they have gone from here. So in this class, how many people are available now? Only 22, because the 3 I have sent them away, they are not there. So I have sent them away, I have got only 22 people. So I have to choose from 22 people. How many people I have to choose? 10 people I have to choose, right? Because net effect, we have to have 10 people joining. So from 22 people, we have to choose 10 people, and that's how we'll get the required number. So let's go about doing this. In order to select the number of students, we have case 1. The 3 students join. So remaining 7 have to be selected from remaining 22, right? Because 3 it's selected and they're put aside. So in how many ways you can do it? Number of ways of doing this. Is 22C7, right? Now, case 2, where the three students don't join. So, they are kept aside. Therefore, number of students available is 22. 25 minus 3, 22. And 10 students have to be chosen. Selected. Therefore, number of ways of doing it. It is from 22, you are selecting 10. 22C10. Now, total number of ways of, what is it called actually? Total number of ways of choosing, of selecting the students. Is 22C7 plus 22C10. If you want, you can sit and multiply. It's not worth it. It's a huge number. You can leave it here. So that's the answer, 22C7 plus 22C10. If need be, we can multiply it, but it's huge. So we can leave it here. That's about our problem number 10. Now we come to problem number 11. What does it say? In how many ways can the letters of the word assassination be arranged so that the S's are all together? Lucky Mississippi question. There was that Mississippi question in the exercise where they they ask us to find the number of cases where the I's are not together. That means you should find out cases where I is together, you should find out total, you should subtract, get the answer. But here it's not like that. Question is, find the number of cases where S's are together, right? And when they come together, we join them, we form them a capsule, and that's how we treat it. So, there is already a breakup about this assassination given to us. I think assassination is a 13-lettered word, 13-alphabet word, where there are 3 A's, there are 2 I's, there are 4 S's, 2 N's, 1 O and 2 T. Because the S's have to be together, the S's will be fused together and they will form one capsule and one unit. So you have the S unit. So what are we left with? We are left with 3 A's, 2 I's, S capsule, 2 N, 1 O, 2 T. So how many are there? 3, 4, 5, 6, 7, 8, 9, 10, 11. So you've got those 11 things that is fused together, and wherever the repeats are coming, we are going to account for those repeats and we are going to get the answer. I hope it's correct. 3, 4, 5, 6, 7, 8, 9. Oh, there's only one T. Yes. So that's a breakup. We are going to fuse the S's together as we always do here. We fuse the S's together to form a single unit. The new word. So the new word now has 3A, 2I, 2N, 1O, 1T and S unit. So, number of ways in which the word has S's together. Lucky, because if it's the same thing, you don't have to look at the internal combination. Otherwise, if the words are different, you have to have the internal combination also. It's not required here. It is, as we counted, 3, 4, 5, 6, 7, 8, 9 and 10. So 10 factorial divided by the repeats. 3 factorial, 2 factorial, 2 factorial. We can solve it. I think it's solvable. We can solve it. 3 factorial can cut 4, 5, 6, 7, 8, 9, 10. And these are 2's. 2 into 2, 4. Let's get cut. And then let's see what can happen here. You could have had maybe 8, 8 5s are 40, and okay, let's go with like this. 72 into 7, been doing 504. Then we have 6 4s are 24, and 30, then into 5. So that is 20, 10, 12, 15. 1 5 1 2 0, and that's 0 over there. 00. In so many ways you can have the arrangement of the alphabets from the word assassination so that the S's are together. That's all about this chapter. We finish the chapter here. The new video we come with the next chapter. Thank you.